Hey everyone, we are looking at discrete variables still, and today we're really going to look at the standard deviation. That'll be like the end goal for what we're doing today. So our situation here is we have a car dealership. They keep track of the sales made during each hour of the day. X is our random variable, and it is the number of cars sold during the first hour of business on a randomly selected Friday. Here's the distribution for our random variable x. Again, x is the number of cars sold during that first hour on some Friday. So from our distribution, we can see that they sell 0 cars with a probability of 0.3 or 30%. 1 car sold, probability of 0.4, and so on. It's a valid probability model because these probabilities all add up to 1 for the grand total. And each individual probability is between 0 and 1. Okay, so one thing I wanted to make sure we did in this video was display this probability distribution as a histogram. You see these things presented as histograms pretty often, so I wanted to make sure we covered that. So the histogram, very easy. The y-axis is going to represent our probability, the probability of x. Maybe I should just go with prob. Okay, and then the x-axis will be our random variable. So we went from like 0 to 1, 2 cars sold, 3 cars sold, makes it a little bigger, up to 4. No, we actually ended at 3. What did I even do that for? No big deal. Okay, so the probabilities, they range from like 0 all the way up to 0.4. So put 0.1 there, 0.2 here, 0.3, 0.4, and 0.5. Okay, so if you remember with the histogram, all the bars touch. And typically they encompass like intervals of data, but this is easy enough just to separate. So we sell 0 cars with a probability of 0.3. There we go. 1 car, probability of 0.4. Yeah, making all kinds of mistakes here. 2 cars sold, probability of 0.2. Okay, fantastic. And 3 cars sold, probability of 0.1. So the reason I'm making the histogram this time as well is we are talking about variability, which is how spread about is the data. So that should sound pretty familiar to you. And the mean measures the center of the data set. So when you look at this histogram, I think it's easier to kind of try to pick out where does the center occur. Probably somewhere like right in this area, 1 point something cars. We'll calculate it here in just a second though. The spread, pretty easy to find. It ranges from 0 to 3. There's no outliers. That's something else that's very easy to see. And then you can also describe the shape of this random variable when you create a histogram. We can see that it looks like it might be slightly, very slightly skewed to the right, just because of this. Okay, so calculating the mean. The mean, by the way, has another name. They are interchangeable in this case. The mean might be called the expected value. So if you're ever asked to calculate the mean of a random variable or the expected value of a random variable, they really refer to the same process. If you remember from the other video, the mean of a random variable x is equal to each observation times each probability, and you actually take the sum of all those things. It's the sum of each value multiplied by its associated probability. So one thing you might be thinking is, well, we're calculating a mean, so we need to divide by the number of observations, but that's already been done here. Dividing by the total number of cars sold has already been accounted for when you created this probability distribution. So that part's been done for us. When we multiply by the probability, we're already accounting for the total number of cars sold. Okay, so let's actually calculate this then. The mean of x equals. So the first thing we would do is 0 times 0.3 And then we'd add the next value and its associated probability. And I'm just getting these straight from the table up here. So the next thing would be 1 times 4 plus 2 times 0.4, 2 times 0.2 plus 3 times 0.1. And so the mean of this random variable x is going to be equal to, I'm not real sure, let's figure it out. You can do this all in one step on your calculator. So we've got, I don't really need to do 0 times 0.3 or 1 times 0.4. So 0.4 plus 2 times 0.2 plus 3 times 0.1. Okay, so we get 1.1. Now, that's the actual value of the expected number of cars sold. So on any randomly selected Friday, you would expect the mean number of cars sold to be 1.1. That value is kind of hard to interpret as it is. One thing you can do to make it easier to comprehend, I guess, is maybe on average, not we, but the dealer is expected to sell. The dealer is expected to sell 11 cars every 10 Fridays. So it just kind of accounts for, we can't sell 1.1 cars, and this might make it, I don't know, make a little bit more sense to you. If we looked at 10 Fridays, we would expect the dealership to sell 11 cars. That's it. And like I said, you can see that pretty clearly from this distribution. It looks like the center is right here at the 1. It's skewed to the right, so it's pulling the mean in that direction just a little bit. So while 70% of the data comes from these first 2 columns, the 30% and 40%, so 70% total, but still it's a little bit skewed this direction, so it pulls the mean into that direction. So that's how we got the mean of 1.1. Okay, the standard deviation, kind of the same idea. If you remember the standard deviation, it is the average distance to the mean, maybe like the typical distance to the mean. And so that's what we're going to do to calculate the standard deviation here for this random variable. The typical variation, right? So maybe we'll start with the variance, how we find the variance. So the variance, it's this squared amount. Standard deviation squared literally is the variance. And so how we find the variance is take each observation, subtract the mean, so that way we get the distance to the mean. And then remember, the negative values can really throw off the total amount of variation, so we square it. The squaring just gets rid of the negative values. We're trying to look at the distance to the mean. We're not so concerned with positive and negative values. And then multiply this by the probability. The probability of this individual value. Now, just like we did with the mean, we need to sum all of those things together. We're going to find the total amount of variation. So it really is, it's each observation minus the mean squared and then multiplied by the probability. So let's calculate the variance for this. The variance of our random variable x is equal to, first value is 0, minus the mean, or the expected value, which we got is 1.1, and then squared times 0.3. move on to the next value. So now we'll do 1 minus 1.1 squared times 0.4. And again, I'm just getting the 1 and the 0.4 from the table that we made, or that was given up here. Almost done then. Plus 2 minus 1.1 squared times 0.2 plus 3 minus 1.1 squared times 0.1. Very hard to see at the end there. Okay, I am going to go ahead and rely on the calculator for this. Kind of preference at this point too. You can break down each piece individually, like just do 0 minus 1.1 squared times 0.3 and write its value down here. I'm going to go ahead and try to just do all of this in one step without making a mistake. So I've got 0 minus 1.1 squared times 0.3 plus 1 minus 1.1 squared times 0.4. Now you're probably better off just doing this piece by piece. Might have like far fewer errors that way, but I'm kind of lazy, so 2 minus 1.1 squared times 0.2. Finally, 3 minus 1.1 squared times its probability of 0.1. All right, so I got 0.89. And again, that's the variance. That's the total amount of error, of squared error to the mean of 1.1. So now what we need to do to actually find the standard deviation, this never changes. The standard deviation is always the square root of the variance. Standard deviation is equal to the square root of the variance. And so that's why the standard deviation, you see the square root of a square, really just cancel each other out and you're left with standard deviation of x. So if we apply this to our variance here, square root of 0.89 0.9. We get 0.94. Fantastic. .94. So to interpret this one, you can go with something like pretty close to what we did here. On average, the amount of cars sold varies by approximately 9 cars for every 10 Fridays total. Or just maybe round that up to 1 and say that every Friday morning, the amount of cars sold varies by 1 car. So they typically sell between 0 and 2 cars, which you see is pretty obvious when we look at our histogram. Typically, they're going to sell between 0 and 2 cars. Very rarely are they going to get up here to 3. And it doesn't vary like that altogether. It varies to the mean. Standard deviation is a typical error to the mean. Okay, I think that's enough for this video. We'll practice interpreting and calculating standard deviations in class. But anyhow, thanks for watching. See y'all in class. Bye-bye.